Hello learners, welcome to my YouTube channel. That is Math Chemistry. With you here is Mwalimu Zakaria. Today we have Chemistry Form 4. That is the topic of acid, bases and salts. If you remember the last lesson, we discussed comparing the strengths of acid and bases, where we took the factor affecting the second one, which was the pH, the third one, which was the electrical conductivity, and the fourth one, which was the chemical reaction. Today here we have lesson 3, effect of solvent in acid-base character. First, let's see a solvent. Solvent is a substance capable of dissolving another substance known as solute to form homogeneous mixture called a solution. Always, we normally have three things. One is the solute. Second, we have something called the solvent. And third, we have the solution. So solute, this is the solid substance. What about the solvent? This is the liquid substance that dissolves the solute, meaning this is the liquid substance that dissolves the solid. Okay, we have the solution. What is the solution? Solution, this is the mixture of the solute. You have the solute with the solvent, meaning if the solute and the solvent, if they dissolve, they form the solution, meaning that is the solid and the liquid that you have. Let's say you have sugar for the solid and you have liquid for the water. So the sugar and the water can dissolve to form sugar solution. Now solvent, from this now here, this is the liquid substance. So this is the substance capable of dissolving another substance known as the solute. So the solvent dissolves the solute to form a homogeneous mixture, meaning it forms one solution. But if they are not dissolved, it forms heterogeneous solution, meaning it forms two layers. In B, we have a polar molecule. What is a polar molecule? This is a molecule which behaves as if it is negatively charged in one end and positively charged in the positive end, meaning it has both the charges. It has both the negative charge and it has the positive charge. Example of it is water. It has negative hydroxide end and positive hydrogen end, meaning if you have water it is H2O. So it's made up of hydrogen ion, which is positive, and is made up of hydroxide ion, which is negative. So it has the both charges, both the negative charge and the positive charge. That is now water. Second, let's see nonpolar compound. So what is nonpolar molecule? It refers to a molecule or bond that does not have separation of charge, meaning it don't have separation of charge. What do you mean separation of charge? Meaning there is no significant difference in electronegativity between atoms involved. Example of nonpolar, that is methylbenzene, meaning it don't have both the charges, or it don't have separation of both charges, both the negative charge and then the positive charge. Next, we want to see differences in properties of hydrogen chloride gas when dissolved in water and methylbenzene. We want to see now the difference when hydrogen chloride gas is dissolved in water or in methylbenzene. So meaning we have our solvent. One solvent we have water, and another solvent we have methylbenzene. Water is a polar molecule, while methylbenzene is non-polar molecule. When hydrogen chloride gas is dissolved in water, an ionic solution is formed, while when dissolved in methylbenzene, a molecular solution is formed. What do we mean? We mean that when hydrogen chloride gas is added into water, it dissolves in water and it dissociates to produce hydrogen ions. These hydrogen ions are the ones which are responsible for the acidic property. Let's say we have hydrogen chloride gas. If we have the hydrogen chloride gas, it dissociates in water, meaning it dissolves. Dissociate means to dissolve, produce the hydrogen ion and the chloride ion. So meaning it dissolves to produce a hydrogen ion. And these hydrogen ions are the one responsible for the acidic property. Now, second, we have when hydrogen chloride gas is dissolved in methyl benzene. What happened? It dissolved in methyl benzene, but its molecules do not dissociate. Hence, no hydrogen ion are produced, meaning methyl benzene is a nonpolar compound. There is no separation of charges. When it dissolves, it does not dissociate. If it does not dissociate, meaning there is no production of hydrogen ion. Does not dissociate. If does not dissociate, there is no production of hydrogen ion. If there is no production of hydrogen ion, does it have effect on the litmus paper, or does it have acidic property? No, it don't have acidic property. That is why in methyl benzene, the hydrogen chloride gas does not dissociate. No acidic property that it has. Let's go now to next. So next we want to say now the property of hydrogen chloride gas in methyl benzene and in water. Different property. One we want to see the effect on litmus paper. Another we want to see electrical conductivity. Another one we have the reaction with metal or metal carbonates. One, we have effect on litmus paper. What happens when hydrogen chloride gas is dissociated in water? It turns blue litmus paper to red. What is the reason? When hydrogen chloride gas is added to water, it is ionized in water to produce hydrogen ion, meaning it dissociates in the water to produce hydrogen ions, which are responsible for the acidic property. Thus, blue litmus paper turns red. The property that we are seeing here is the blue litmus paper turns to red. Why? This hydrogen chloride gas dissociates in water to produce hydrogen ion, and hydrogen ion is the one that has acidic property. So acid turn blue litmus paper to red. Let's see solution of hydrogen chloride gas in methyl benzene. The blue litmus paper remains blue, meaning there is no change, or you can say there is no change in the litmus paper. Reason: solution of hydrogen chloride gas in methyl benzene is a molecular solution. Hence, no hydrogen ion is produced, which are responsible for the acidic property. Even we have seen the property, meaning hydrogen chloride gas does not dissociate in methyl benzene to produce hydrogen ion. If there is no production of hydrogen ions, hence there is no effect on the acidic property, meaning there is no acidic property. The acidic property, that is production of hydrogen ion, is what will turn the blue litmus paper to red. So if there is no production of hydrogen ion, the solution remain blue. Second, we have electrical conductivity. Solution formed conducts electricity. What is the reason? Solution of hydrogen chloride gas in water is ionized to produce free and mobile ions, which are responsible for the electrical conductivity, meaning this solution here, it is conducting electricity. Why? The solution of hydrogen chloride in water is ionized to produce free and mobile ion. The free and mobile ion are the ones which are responsible for the electrical conductivity. Let's see when hydrogen chloride gas is dissolved in methyl benzene. Solution of which hydrogen chloride gas in methyl benzene is a molecule, meaning it does not dissociate. Hence, there is no free and mobile ions. If there is no free and mobile ions, the solution do not conduct electricity, meaning the solution is not conducting any electricity. Why? Because there is no free and mobile ions, which are responsible for electrical conductivity. Let's see to that property, that is reaction with metal and metal carbonate. What happens when hydrogen chloride gas is dissociated in water? Effervescence occurs when reacted with magnesium or zinc carbonate. What is the reason? The solution is ionized to produce hydrogen ion, which react with metal. When this solution reacts with magnesium, it produces hydrogen ion, or when reacted with metal carbonate, it produces carbon dioxide. So the production of hydrogen gas or the production of carbon dioxide gas is the one which producing now the effervescence. This effervescence due to production of a gas. So meaning either hydrogen gas or carbon dioxide gas is produced. What about when we have hydrogen chloride gas in methyl benzene? Is there any effervescence? Solution does not produce effervescence, meaning there is no production, there is no effervescence that is produced. What is the reason? Solution of hydrogen chloride gas in methyl benzene is amolecular. Hence, absence of hydrogen or carbon dioxide. Means there is no production of hydrogen gas and there is no production of carbon dioxide. If there is no production of any gas, meaning also there is no effervescence, because effervescence is due to production of a gas. Let's see now to ammonia gas. We want to see now differences in properties of ammonia gas when dissolved in water and methyl benzene. NB, when ammonia gas is dissolved in water, ammonia solution is formed. That is ionic solution. But when dissolved in methyl benzene, a molecular solution is formed. What is the reason? Let's see here. When ammonia gas is added into water, it dissolved in water and dissociates to produce hydroxide ion, which are responsible for the basic properties. Meaning, if ammonia gas is added into water, it dissolves and dissociates to produce hydroxide ion. And this hydroxide ion is the one which is responsible for the basic property. That's meaning we are forming ionic solution. But when ammonia gas is added to methyl benzene, it dissolves in methyl benzene, but its molecules do not dissociate. Hence, no hydroxide ion are produced, which are responsible for the basic property. Meaning, there is no hydroxide ion produced. If there is no hydroxide ion produced, there is no basic property. Let's see now different property of hydrogen chloride gas. Different properties of hydrogen. Now, the property of hydrogen chloride gas, we have two. Let's see the effect it has on litmus paper, and we see its electrical conductivity. What happened to solution of ammonia gas in water? The effect that it has on litmus paper. Solution turns red to blue. Remember, ammonia gas is the only basic gas that we have in high school. Reason, ammonia gas dissociates in water to produce hydroxide ions, which are responsible for the basic properties that turn red litmus paper to blue. Meaning, this litmus paper is turning to blue. Why? Because ammonia gas dissociates in water to produce hydroxide ion. And this hydroxide ion is the one that is responsible for the basic property. Always bases, they change red litmus paper to blue. That is why the litmus paper turns from red to blue. What happened to the solution in methyl benzene? Solution has no effect on litmus paper. Why? Solution of ammonia gas in methyl benzene is a molecular solution. Hence, no hydroxide ions produced for the basic property. If there is no hydroxide ion produced, there is no effect on the litmus paper. What is the electrical conductivity? Solution of ammonia gas in water, it conducts electricity. Why? Solution of ammonia gas in water dissociates to yield free and mobile ions that are responsible for the conductivity. Meaning, if this ammonia gas dissociates in water, it dissociates to yield free and mobile ion. And the free and mobile ion are the ones responsible for the electrical conductivity. What happened to ammonia gas? Solution does not conduct electricity. Why? Solution of ammonia gas in methyl benzene is molecular, hence absence of free and mobile ion. There is no free and mobile ion, yes, thus there is no conductivity. Let's say now some simple question that come from this concept, the question that we expect now in exam. Question 1, we have a piece of blue litmus paper is dropped into a gas jar of hydrogen chloride gas. A drop of water was then added into the gas jar. Still the observation made. What observation do we have? Even we can think of it. We have blue litmus paper. When it is dry, does a dry gas have effect on litmus paper? No. Why? Due to absence of moisture. But when water is added, a drop of water was then added into the gas jar. When water was added, what happened? The water always dissociates the hydrogen chloride gas to produce hydrogen ion. The hydrogen ion is responsible for changing the blue litmus paper to red. Let's say now the observation that we have. Blue litmus paper remains blue in dry hydrogen chloride gas. Yes, we say due to absence of moisture. But on addition of water, the blue litmus paper turns to red. Here, as we said, if we add water, the hydrogen chloride gas dissociates to produce hydrogen ion, which is responsible for the acidic properties. Explain the observation. Let's try to explain it. Dry hydrogen gas lack free hydrogen ions lack free hydrogen ion, meaning when it is dry, there is no moisture. On addition of water, hydrogen chloride forms hydrochloric acid, which ionizes to release hydrogen ion. On addition of water, it releases hydrogen ion, and the hydrogen ion is the one which is responsible for the acidic property. Thus, it turns blue litmus paper to red. Let's see question 2. A piece of red litmus paper is dropped into a gas jar of dry ammonia gas. A drop of water was then added into the gas jar. First of all, we have it is added to dry ammonia gas. Always a dry gas has no effect on litmus paper. Why? Because due to absence of moisture. And get that one from me. Due to absence of moisture. A drop of water was then added. If water is added, meaning here it is ammonia gas. The ammonia gas dissociates in water to produce hydroxide ion. Hydroxide ion is the one responsible for the basic property, meaning it turns the red litmus paper to blue. So what do we have here? The red litmus paper remains red in dry ammonia gas due to absence of moisture. On addition of water, the red litmus paper changes to blue. What is the reason for that one, or the explanation? Dry ammonia gas lacks free mobile ions, but on addition of water, the dry ammonia gas forms ammonium hydroxide solution, which ionizes to release hydroxide ion, which is responsible for the acidic property, which changes the red litmus paper to blue. So it changed the red litmus paper to blue. Next, let's see, we have another. So this is KCSE question. It is KCSE 2013, paper 1. It was number 9 question. We have a question here. Aqueous hydrogen chloride gas reacts with potassium magnate 7 to produce chlorine gas, while solution of hydrogen chloride gas in methyl benzene has no effect on potassium magnate 7. Explain the observation. Meaning here we have hydrogen chloride gas in water. Meaning this aqueous hydrogen chloride gas in water. In water always it dissociates. But hydrogen chloride gas in methyl benzene, does it dissociate? No. Let's try to explain. Hydrogen chloride gas in water ionizes to form hydrogen and chloride ions, hence showing acidic property due to presence of hydrogen ion. In methyl benzene, it remains molecular form and does not display acidic property, meaning it does not dissociate. So if it does not dissociate, the solution lacks the acidic property. That is why there is no production of chlorine gas. That is our lesson for today. Here it is self-trial question. You try this question for yourself. You try them. This question 1, question 2, question 3. Try to answer this question. You use now the concept that we have learned now to answer it. Remember, chemistry is the easiest subject that we have in high school. From the one suggestion, chemistry, chem is try if you break it. So try this self-trial question and share the answer in the comment section. Also, make sure you like the video, you comment it, and you share to your friends. Thank you. Welcome.